Have you ever wondered how many of my friends actually like pineapple on their pizza? Have you ever wondered how many of my friends actually like pineapple on their pizza? This seems like a simple, almost silly question, something you might ask over lunch without a second thought. But within that curiosity lies the very beginning of a powerful journey. It is the seed from which the mighty trees of data analysis, statistics, probability. This one small question is the first step toward understanding the world, not just based on what we think or feel, but on what we can actually observe and measure. It's the start of replacing guesswork with facts, and in today's world, knowing the difference is more important than ever. We are going to gently peel back the layers of these big-sounding ideas and reveal the simple, practical tools hiding inside. Forget about complicated formulas or dense textbooks for now. Instead, we will use everyday examples, like that pizza preference, to explore how we can collect information, make sense of it, and even predict what might happen next. We will discover that you are already an amateur statistician, making data-driven decisions every day without even realizing it. Our goal is to make those processes conscious, clear, and easy to master, transforming you from a guesser into a confident data explorer. The beauty of this field is that it starts with things you already know. You know how to ask a question. So, what exactly is this mysterious thing we call data? In the simplest terms, data is just a collection of facts. These facts can be numbers, words, measurements, or even simple yes or no answers. Think of it as raw information, the basic building blocks for understanding a topic. If you measure the height of every student in your class, that list of heights is data. If you write down the favorite color of each of your friends, that list of colors is also data. Data is born from observation and questioning. We look at the world, ask a question, and then carefully record the answers. Let's go back to our pizza example. You ask 10 friends, "Do you like pizza?" and write down their answers. Maria, yes. Tom, yes. Aisha, no. Sam, yes. Chloe, yes. David, no. Liam, yes. Fatima, yes. Ben, no. Olivia, yes. This list of names and answers is your dataset. Bring order by sorting and counting, tally each answer. 7 said yes and 3 said no. Now you can confidently say most friends like pizza. It is crucial to understand that data is not opinion. My opinion might be, everyone loves pizza, but the data shows 3 out of 10 do not. Data provides evidence that can support or challenge our assumptions. It grounds our understanding in reality. Whether you are counting types of cars that pass your house, recording daily temperatures for a week, or listing the different species of birds you see in the park, you are collecting data. You are gathering the factual ingredients you need to cook up a conclusion. It's about listening to the world around you, gathering its answers, and using those answers to navigate it more wisely. Let's learn how to listen more effectively. Imagine you are planning a class party. You could just guess what snacks to bring, maybe buying what you like best. But what if most of your classmates dislike your favorite chips? Your party might not be as fun as it could be. A better way is to ask. By collecting answers, or data, you can ensure you bring snacks that most people will enjoy. This simple act of collecting information to make a better decision is the very heart of statistics. It's about listening to the world around you, and using those answers to navigate it more wisely. Data is just facts, numbers, words, measurements, even yes or no, collected to answer a question. Sort, tally, and summarize to turn a jumble into a clear answer. Graphs turn data into pictures your brain understands in a glance. The taller bar shows more, and the gap shows how much more. Bar charts, line graphs, pie charts, different tools with the same goal. Clarity. Learning to read and make them is like gaining a superpower. It lets you find and share the stories hidden all around you. When our data consists of numbers, like ages or test scores, we can summarize with single numbers. Let's meet the 4 most common measures: mean, median, mode, and range. We will use 5 cousins' ages: 9, 10, 10, 11, 15. First, the mean, the average. Add up the numbers, then divide by how many there are. 9 plus 10 plus 10 plus 11 plus 15 equals 55. Divide by 5 to get 11. The mean age is 11. It uses all values for a balanced center. The median is the middle number when ordered: 9, 10, 10, 11, 15. The middle here is 10, so the median is 10. If the oldest were 45, the mean jumps, but the median remains 10, more robust to outliers. The mode is the number that appears most often. Here, 10. There can be more than one mode, or none if all values are unique. Mode also works for categories like most popular, topping, or color. The range measures spread, largest minus smallest. 15 minus 9 equals 6. Small range means clustered, large range means spread out. Together, these four measures powerfully summarize data. Now let's shift from what has happened to what might happen. Probability, the mathematical word for chance. Probability measures how likely an event is, from 0 to 1. 0 is impossible, 1 is certain, most things are in between. A fair coin has two equally likely outcomes. Probability of heads is 1 out of 2, 1, 2, or 0.5 or 50%. With 3 red and 1 blue, the chance of blue is 1 out of 4, 1, 4, 0.25, 25%. Red is 3 out of 4, 0.75 or 75%. More ways to happen. Higher probability. Count the favorable outcomes. Divide by total outcomes. Probability helps with predictions and decisions, from board games to weather forecasts. It turns uncertainty into informed expectation. Reading is one thing, doing is better. Become a data detective with paper and pencil. Which of these three superpowers would you rather have? Flight, invisibility, or super strength? Find at least 10 people, friends, family members, classmates. Ask each person and write down their choice carefully. When you have at least 10 answers, your data collection is complete. Create 3 columns labeled by superpower and tally each response. Add up the tallies and write the totals. Now draw a simple bar chart with a clear title, making bar heights match your counts. Which bar is tallest? That choice is the mode, the most popular. Count how many people you surveyed, say 10. If 4 chose flight, the probability a random person from your group picks flight is 4 out of 10, 0.4 or 40%. You just used your own data to calculate a probability. Ask, collect, organize, visualize, and analyze. Your mini research cycle is complete. From a simple question about pizza to a mini survey about superpowers, we have journeyed through the foundations of data and probability. Data is a collection of facts born from curiosity. We sort and picture them to see hidden stories. Mean, median, mode, and range each tell us something unique. Probability helps us measure what might happen next. Stores, doctors, and even video games use data about the past and probability for future decisions. Understanding the basics helps you question headlines, understand reports, and make smarter choices. The cycle from question to conclusion turns noise into signal, the path from guessing to knowing. The world is full of answers, and you now have the tools to discover them. Keep asking questions, keep collecting answers, and keep looking for the stories numbers tell. Start with a simple question, collect your data, and see where the facts take you.